Hello friends, welcome to my YouTube channel RF Design Basics. In this video, we are going to learn about two-port networks and we will be seeing the different types of parameters associated with two-port network. So, two-port network is defined as any linear network in which we have two sides. One side is having voltage V1 and input current I1, and other side we have voltage V2 and input current I2. Here this is a linear network. That means it does not contain any active devices like diodes or BJTs, etc. So here the parameters what we can write is, the first parameter is Z parameters, which gives us the impedance involved in different form: input impedance, output impedance, transfer impedance, etc. The second one is called Y parameters, which gives us the admittance involved with this. So input admittance, output admittance, and transfer admittance. There are two more parameters, which is H and G. H is called hybrid parameters. Hybrid parameters. Why it is called hybrid parameters? Because it will give you the input impedance, output admittance, as well as the voltage and current gain. Similarly, G parameters, which is called inverse hybrid parameter. Inverse hybrid parameters. This gives you input admittance, output impedance, and voltage and current gain. So basically we are going to learn these parameters calculation one by one, and then we will see what are the methods of calculating the different parameters. So let us take the first one, Z parameters. For Z parameters, our equation will be, in terms of matrix we write V1 V2 equal to Z11 Z12 Z21 Z22 multiplied by I1 I2. Remember, the current direction is always incoming to the network. So using this, we can separate them as two equations. The first equation will be V1 equal to Z11 I1 plus Z12 I2. Similarly, V2 will be equal to Z21 I1 plus Z22 I2. So to write the individual Z parameters, which is Z11, Z12, Z21 and Z22, we need to put certain condition for the second term. For example, if I want to write Z11, so it will be V1 by I1 only if I2 equal to 0. So I can write Z11 is V1 by I1 when I2 equal to 0. Similarly, this Z12 will be Z12, this is Z12 will be when I1 is equal to 0, V1 by I2. So V1 by I2 when I1 equal to 0. And Z21 is V2 upon I1 when I2 equal to 0. And lastly, Z22 will be equal to V2 upon I2 when I1 equal to 0. Now let us try to understand the names of these parameters. So first we will write Z11 and see the property. So you can see Z11 is voltage and current ratio, so it's a impedance. When I2 equal to 0 means port 2 is open circuited. So this is called open circuited input impedance. Z12 is transfer impedance. Between port 1 to 2. So from port 1 to port 2. Similarly, Z21 is transfer impedance from port 2 to 1. And Z22 is output impedance. So it's open circuited output impedance. We can write open circuited output impedance. So this is the formula for Z11, Z12, Z21 and Z22. Similarly, if I want to write Y parameters, for Y parameters our expression will become I1, I2 equal to Y11, Y12, Y21, Y22 into V1, V2. So this is the expression. Here we have I equal to Y into V. So the formulas are, first of all we'll write two equation. So it is I1 equal to Y11 V1 plus Y12 V2, and I2 is Y21 V1 plus Y22 V2. So you can see if I put V2 equal to 0, I can write Y11. So Y11 is I1 upon V1 when V2 equal to 0. Y12 is I1 upon V2 when V1 equal to 0. Y21 is I2 upon V1 when V2 equal to 0, and finally Y22 equal to I2 upon V2. I2 upon V2 when V1 equal to 0. So this is the formulas for Y parameters. So we can name these parameters as Y11 is short circuited input admittance. Y21 is transfer admittance between 2 to 1. Y12 is transfer admittance 1 to 2. And then finally we have Y22, which is short circuited output admittance. Now we will see H parameters. For H parameters, we are going to take the expression in this form. So left side we have V1 and I2, and right side we have I1 and V2. This is H11, H12, H21 and H22. So the expressions are V1 equal to H11 I1 plus H12 V2 and I2 equal to H21 I1 plus H22 V2. Now let us put this condition one by one and find out H11, which will be V1 by I1 when V2 equal to 0. H12 is V1 by V2 when I1 equal to 0. H21 is I2 upon I1 when V2 equal to 0. And lastly, we have H22 equal to I2 upon V2 when I1 equal to 0. And now let us analyze this. What are these parameters meant? So the first one, H11 is an impedance. So we can say it's when the port 2 is short circuited. So this is short circuited input impedance. Then we have H12. H12 is I1 equal to 0, that means open circuit. Open circuited voltage gain. It's voltage ratio, so it's voltage gain. Then we have H21. H21 is current ratio when there is short circuit. So we will call this as short circuited current gain. Then we have H22, which is I2 by V2, it is admittance, and I1 equal to 0, that means open circuited admittance. So we have found H parameters. Similarly, we can define G parameters. For G parameters, we just switch the side of the H parameters equation, I1 V2 in the left side and V1 I2 in the right side. So the equation will become I1 V2 equal to G11, G12, G21, G22. So right hand side will be V1 I2. The equations are I1 equal to G11 V1 plus G12 I2. V2 equal to G21 V1 plus G22 I2. So we can define various parameters as G11. G11 is I1 upon V1 when I2 equal to 0. G21 V2 upon V1 when I2 equal to 0. G12 here is I1 by I2 when V1 equal to 0, and G22 equal to V2 upon I2 when V1 equal to 0. And we can name them as, the first parameter is G11, G11 is I1 V1 ratio, that means it is admittance when port 2 is open circuit. So it is called open circuited input admittance. Then we have G12. G12 is called short circuited current gain. G21 is called V2 by V1, so it's open circuited voltage gain. And finally we have G22, which is equal to V2 by I2, that is impedance, so short circuited, V1 is 0, short circuited output impedance. So in this video we have learned about Z parameters, Y parameters, H and G parameters. So Z parameters means Z matrix will be also inverse of Y matrix and vice versa. That means Y will be inverse of Z, H will be inverse of G, and G will be inverse of H. So if you know one matrix, we can find the other matrix. In next video I will be solving few basic problems and few advanced problems based on Z, Y, H and G parameters. Thank you.